JAMB physics students, what I'm about to show you is the ultimate JAMB physics calculation hack. Once you learn this, most of your calculation problem in JAMB physics is solved. And what is this? Most times, JAMB like to give you a constant situation and they would like you to vary some parameters against the other. And then this comes in so many ways. For example, they can give you an equation, not even an equation, they can give you a question on t equals 2 pi square root of L over G. They can give you something on F equals K times Q1 times Q2 divided by R squared. So they can begin to say that, oh, when the temperature is halved, what happens to the length? When the force is doubled, what happens to the distance apart? Now, they like to ask you these kind of questions very well. So in this video, I'm about to teach you the ultimate way to always deal with it. So this is the first thing you need to do. I will give you in the basic way. You need to be able to extract the constant term out from the terms that is varying. For example, imagine I write all of this jargon. I just say that K equals U over square root of V, maybe square root of VG and all of that. Now, let us say I now say that for this particular system now, I want to compare how K is varying with G. So what I want to compare in this particular expression is the variation of K and G. So what do I need to do? What I need to do is that I need to separate every other guy. So under constant, so this U is constant, this V itself is constant. So how do I separate this? So what you need to do is that you need to break this down into their product separation. What do I mean by that? So K is U divided by square root of Vg according to indices will be square root of V multiplied by square root of G. So you have separated them like that. Now the next thing you need to do now is that the constant term, let them be together in one group, and the varying term, let them be together, let them be separated. So what I mean by this is that here you can now have that K equals U over, since V is constant, so you can leave it under V, then multiplied by 1 over square root of G. Now, so when you notice this thing, you see that I've been able to separate 1 over square root of G, which is a varying guy. Now, but the reason why it is 1 over square root of G is because G is actually the denominator, so I cannot write it as square root of G when I'm separating it. It has to be 1 over square root of G. Now, the last thing you need to do now is that, you see, this entire guy is a constant, so you don't need to stress yourself about it. Just name it as a constant. Maybe you can use C to represent it. So what does that imply? That implies that you have that K equals a constant C multiplied by square root of 1 over G. And when you do that, that is C over square root of G. The next thing you can do here is to cross multiply. That means that K times square root of G equals to a constant. And once you have been able to do this, then you finish it up by saying that if K times square root of G equals to this guy, which is a constant, that implies that the product of K multiplied by root G will always be constant. So you can begin to vary it. That means that K1 root G1 will be equal to K2 root G2. In fact, as many as possible. Now, let me use one of these guys that I have here as an example. Let me start with T equals to 2 pi square root of L over G. So if I have T equals 2 pi square root of L over G, let's say I want to vary T with L. To vary T with L, so I will do the same thing, separate everything. So we have something like 2 pi multiplied by square root of L over square root of G. Now that I'm done with the separation, I can bring the constant. One thing is that, you see, 2 is a number, so it's a constant. Pi is also a number, is a constant as well. So I can have this written as T equals, the constant term will come together, that is 2 pi over, we know that G is also a constant as well, especially under this condition, which is square root of G. Then finally, I have square root of L isolated in this place. So what does that tell us? I can represent this entire 2 pi over square root of g as a constant. So I have this as t equals a constant. You can use k this time around if you feel like using k times square root of L. So let me make the constant solve the formula. That implies that t over square root of L equals the constant k. And this is where the variation happens. So you can now say that t1 divided by square root of L1 equals t2 divided by square root of L2. Then you can begin to vary it like that as it goes on and on. Now, let me give you one more before I go. Now, you see this equation of motion where you have S equals ut plus half at squared. So one thing JAMB likes to give you is that they can say that, oh, if the initial velocity, if this body is starting from rest, meaning that the initial velocity is 0 meters per second. So that implies that this expression can easily be written as S equals half at squared. So what they can do here is that they can say that if the acceleration is constant, if this body is moving under a uniform acceleration, what is the distance when the time is doubled? What is the time when the distance is halved or is quadrupled? Any of those things that they can ask you. So what you do is that the same process, separate the constant from the varying part. So here the constant will be your acceleration and 1 over 2, because now you are moving with a uniform acceleration. That means that the acceleration is constant. Hence, the varying thing are s and t. So what do you do next here is that, so this implies that s equals to the constant term. So let the constant term, let it be c times what? Times the t squared term. So we have times the t squared, and then this definitely implies that we have s over t squared equals the constant, and that implies that s1 over t1 squared equals s2 over t2 squared. And with this now, you can insert all of the values that you have been given, then you would then solve for the unknown term there. You can practice this with most of those formulas that you have in your physics, and this will work. In fact, this can also work in chemistry as well. If you like this particular video and you want to see more of it, don't forget to like, comment, subscribe. I'll see you in the next one.